Hi, Terry VanNoy. Welcome to Math Class with Terry V. Hope this video helps you out, and if you enjoy it, please share it, comment, or like it. And you can also go to my website, MathPowerLine.com. It's a math resource blog, lesson videos for students, and other resources for parents and teachers. Give me a call or go to my website or email. All right, let's go to today's lesson. What we have here is a self-quiz. Now, if you've seen my other video series, you know that I teach some basic concepts and then we have some practice problems, which I call problem sets. And for this topic, simplifying irrational expressions, which is reducing algebraic fractions, that's another way to think about it, I've created 4 problem sets. So before you continue with this video, if you have not seen any of these previous videos, under that title right there, you can search for that title on my channel, then I do recommend that you go back and watch those first. Okay, the self-quiz is not much instruction. I put some problems up on the screen on a piece of paper. You try them, you hit pause on the video, and then you'll see if you're right. All right, so let's go ahead and get started if you're ready. All right, we're going to do 4 problems at a time, 8 problems altogether. And what I want you to do is simplify each of these expressions, okay? Notice that numbers 1 and 2 are monomials divided by monomials, okay? They're just algebraic fractions. Look for a GCF, greatest common factor, and cancel out those common factors and simplify and reduce. As we get to 3 and 4, notice how it gets a little complicated. We have a binomial here and a trinomial and a binomial here. All right, hit pause and good luck. All right, let's take a look at our answers. Here's what we've got. Number 1, 5k squared over 2. Notice how it's an improper fraction, but that's okay. In rational expressions like this, we can leave it in that form. So how did we get that answer? Well, as I mentioned in a previous video, and hopefully you've seen it, what we need to do first is factor these out. Okay, 35 is 5 times 7, and k to the 5th is 5k's multiplied together, which takes you a little while here. All right, and of course there's a shortcut I talked about too. 14k to the 3rd is 2 times 7 times 3k's multiplied together. All right, now obviously we've got to cancel out common factors, which would be a pair of 7s, and we've got 3k's on the top, 3k's on the bottom. Now when we put it back together again, which is the simplify stage, you get 5k squared over 2. Number 2, 15p squared. Okay, let's factor that apart. 3 times 5 times p, and 6p to the 3rd is 2 times 3, and we have a p times itself 3 times. All right, let's cancel out some common factors. 3's, a pair of p's. Notice what's left now. We have 5 on the top and 2p on the bottom. All right, let's go to number 3. Now for both of these on the bottom, you can ignore this part. This has to do with restricted values, which is actually part of a Algebra 2 lesson. Okay, we don't need to worry about that. All right, well, let's go ahead and factor this one. 42 n to the 2nd is 6 times 7, so it'll be 2, 3, 7, or 6 times 7, and n squared is n times n. And on the bottom, 12n plus 30. Look for a greatest common factor. That would be 6, which is 2 times 3, if I just kind of combine those steps there. And on the outside, I have 2 n plus 5. All right, again, that's 6 times 2n plus 5. All right, obviously I can cancel out my 2's and my 3's, and that is it. So on the top, 7n squared. On the bottom is my binomial. Notice that the parentheses are no longer needed. Number 4, This is a trinomial. We need to factor it, which is two binomials multiplied together, right? And I have a video series about factoring polynomials like this, so I go over that. You should take a look at that if you need some help. Now, interesting. This is a -1 that I could factor out. Now, when you factor out a -1, you're going to get a -9 and a positive x. Okay? This means that I can actually switch the order. Actually, that's going to be subtract 9. So let me say that again. If you have a subtraction pair in a binomial, you can factor out a -1 and it reverses the order. Now, the reason why you would do that is so that you can match, because I bet in this top fraction you'll have x minus 9 as one of your binomials. So in fact, let's try that. Let's see if x minus 9 would be one of the factors. Well, look, kind of working backwards here, that would be a 7, right? 9 times 7 is 63, and that would be a positive there. So middle term there would be 7x positive and -9x. And that does give me the -2x I needed right here. All right, what does that mean? Well, I can cancel out that x minus 9 binomial, and that leaves me with this answer. All right, now look at these next four. Okay, make sure you look for greatest common factor first, and then factor it out, cancel out your common factors, simplify, and check. All right, check back with me in a few seconds. All right, answers. Again, we can ignore this part here, which has to do with the restricted values. Okay, we don't need to worry about that. And let's go ahead and look at number 5. All right, how are we going to factor this? Well, we're going to have a trinomial here, so to factor that, we're going to get a pair of binomials. I know that it has to be an R and an R, and factors of 50 that add up to 15. How about 10 and 5? All right, that'll give me the 15R middle term that I need. Here I can divide out the GCF of 9. So 9 goes on the outside, and that leaves me with R plus 5. All right, notice how those binomials can cancel each other out. R plus 10 on the top and a 9 on the bottom. All right, very good. Look for a common factor here, and that would be 7. So 7 factored out would give me 7m minus 9. On the bottom, I can factor out a 7 again. So 7 divides into each of those, leaving 2m minus 3. All right, those 7s can cancel each other out. That leaves me with this binomial on the top and that binomial on the bottom. No parentheses needed. All right, continuing on, and I hope that you're doing okay with this. This is a pair of binomials multiplied together, and the same with the bottom, with one little twist that we have to talk about. All right, so we've got n and n for the n squared first term. Now we need factors of 16 that combine to give you 8. All right, what's that going to be? Ah, you're right. That's a -4 and a -4. Okay, now let's check that. -4 times -4 is positive 16. There you go. And a -4n and another -4n combined to give you -8n. Middle term. All right. Let's go on the bottom. This is a GCF of n. All right. Let's go ahead and factor out the n. I'm going to kind of squeeze it in down here. And if I factor out an n, divide an n out of each of those, it gives me n squared minus 8n plus 16. All right. Notice how that will give me the same thing, n minus 4 n minus 4, and all of those binomials are gone. Now if everything's gone on the top, that leaves a 1, and on the bottom it's an n. 1 over n. And finally, let's look at this one. Can you factor that? Take a look if you did this on paper and we'll compare. Greatest common factor in the numerator would be 9, leaving me that trinomial on the inside. In the denominator, we also can factor out a 9. And now notice how my trinomial is this, 7x squared plus 23x plus 18. Now I know that those 9's will cancel out, so I'm going to go ahead and just do that right here in this step. Now I can focus on the factoring on the top and the factoring on the bottom. Alright, so what are we going to do? Well, we know on the top 3x squared can only come from a 3x and an x, so we'll go ahead and put that in. And so now we have a 3 times a 1. Alright, now let's kind of list this out. 10 can be 1 times 10 or 2 times 5. Okay, now we've got to do a little bit of mental math here. Remember, the goal is to get my middle term of 11x. Alright, so if I do 3, and 3 times 1 is 3, 1 times 10 is 10, add those, that gives me 13. Not quite. But if I do 3 times 2 and 1 times 5, that'd be 6 plus 5. That would work. That gives me 11. So I want the 3 to multiply by the 2. Okay, that means that the 2 has to come here. Positive 2. And the 1 has to multiply by the 5. So a 1x times a 5. Okay, hope that you followed that. I have a video on a factor box method which kind of organizes your guesses a little bit better that way. So it's going to be 3x plus 5 and x plus 2. All right, let's look on the bottom. What have we got here? Well, let's try 7x and an x. Okay, now notice how everything's positive here. So again, let's try 7 times 1, and factors of 18 are going to be 1 times 18, or 2 times 9, or 3 times 6. Alright, we need to get a middle term of 23. So 7 times 1 is 7, and 1 times 18 is 18. 7 plus 18 is 25. Not going to work. 7 times 2 is 14. 14 plus 9 is 23. There we go. So we want the 7 times the 2. That means the 2 will go here. And the 1 times the 9. And so the 1x is going to be multiplied by the 9. Alright, obviously these x plus 2 binomials will cancel, and that leaves me with my final answer. Now that challenge was just all in the factoring, okay? The concept is the same. We're going to break apart the numerator and denominator of each of these rational expressions. We're going to cancel out those common factors and simplify and put together what's left. Alright, thank you for trying this self-quiz. I hope it helps you with what you're studying, and look for some more video series that relate to factoring and simplifying. Thanks for watching. Alright, there you have it. I invite you to go to my website now, MathPowerLine.com, or email me or give me a call. The way I work best with students is live online in my classroom. So if I can help you in any way, answer some specific questions, the first lesson with me is free as I show you how everything works. Alright, study hard and take care.